Okay, so today we're going to look at the project. Now this is about the Mega Ball. Several years ago, it reached $1.6 billion. So I thought it'd be interesting to look at something with this. So the points of interest to know, get this, is a ticket is $2. And there are 302,575,350 different combinations. And we use combinations because the order the numbers are drawn doesn't matter. If you're not familiar, Mega Million, there's 5 numbers from, I don't recall what it is. I think it's 1 to 73. And then there's a separate number called the Mega Ball, which is one number from 1 to 26. So I could be mean and make you calculate all the number of possible permutations and combinations, but I didn't. I calculated it for you. So here's what we have. We have the different possible outcomes. So these are our outcomes. This is our probability, this column here. This is how much you win. Again, I stopped at 40 million. There is a purpose to this exercise. Now, our net gain or loss. So remember, the ticket costs $2. So if we pay our $2, $2 million, we end up with $39,999,990. So here, 1 million would be $999,998. Here we dollars, $198. Now remember, gain or loss for every possible outcome. Okay, so we had a glitch here. All right, back to where we were. So these are all winners, and then this is our loser. And these are all the different ways we can win here. And then there's only one way to lose, which is to not be any of those. So we take the probability of our outcome, again, that's this aisle here, the row column there, and we multiply it by our net gain and loss. And now you'll notice these fractions are all over the same number, which is the 302,575,350. So for the time being, we can just ignore that. And so what we're going to do is basically take this, the numerator and all these probabilities, and multiply it by this column. So here I have 39. Let's see, do I have my calculator up? Yes. We have 24 times 999,998, which is 23,999,952. And we do that for all of these. This times this, and we go all the way down. This one is going to be 0. This one here would be negative. And let's see if I can do this in my head. 6, 3, 8, 4, 8, 16, 15, 19, 5. And what is that? Negative 5, 9, 5, 6, 8, 4, 8, 3, 6. Now remember, these are all over this 302,575,350. So what we're going to do is we're going to take these numbers here that we get, all of them. Remember, this one here is negative, and we're going to add them up. And if memory serves me correct, it's something like negative 504 million. And then we're going to divide that by that 302,575,350. And the result you should get is negative $1.67. Now that's when you take and add up this whole column. This will be your expected value. And what this means is, with a $40 million prize on the Mega Millions drawing, if you were to buy every possible combination of them, all 302 million plus, you would actually lose $1.67 for each ticket you bought. So you would actually end up losing money. And that's only assuming that you're the only one that wins the grand prize. The rest of the prizes are the same no matter what. That's how it works. The grand prize can be split between more than one person if there's more than one winner. Now, the other thing we wanted to look at, and this is the part that's really interesting. If you happen to be a lottery player, you may or may not want to take this into account. So if I go and I start here and I add all of these up except the top one, everything but the top one. And if memory serves me correct, it's something like 547 million roughly. And it's negative because, again, this is negative. Now this number, if we change it to positive, just to even it out, we need a positive winnings of that to replace what's in here. So whatever you get, and it's going to be roughly this, if memory serves correctly, that will be what you need. So to run through this again, we figure out our net gain and loss by subtracting 2 from the prize amount. Then it says it right here, probability, that says here, times net gain loss, and that's what you get here. Now, since there's limited space, just keep in mind they're all the fractions, and just simply multiply the numerator times this on all of them. And you'll get this here. Then to figure out the expected value, you take and add everything up and divide by your 302 million. That'll give you an expected value. And again, it should be negative $1.67. Essentially, that is telling you that for every ticket you play, you're going to lose $1.67. Of course, the reality is, for every ticket you play, you're probably going to lose the $2, but that's another matter. Then you go and you add everything but the top amount. Remember, it's multiplied by 1. That's why this works so easily. So you add everything but the top amount, and you'll get something along the lines of negative 547 million. Now, the goal is to make it break even, and that's it, just break even. So, since I have negative 547 million, this prize, or this needs to be positive 547 million. And since that means that this times this would need to be that, and since that's 1, it is simply the 547 million. And that's it simple. What this means is, from a mathematical and a statistical viewpoint, it is not in your best interest to play Mega Millions until the prize amount is over this amount here. So I would just use 550 million as a cutoff. So anytime that the Mega Millions is over 550 million, I believe as of the time I'm recording this, it's something like 900 million. Or maybe not. I don't know. I don't keep track of it anymore that closely. Somebody may have won it recently, but it was climbing up there again. So what we're saying is it's not worth it to play unless it's over, the prize is over that amount. And again, that's also assuming that you're going to be the only one to win. So that's basically what it is. I did the hard part for you, really. I think you can take, it shouldn't take more than 5-10 minutes to do this if you have a calculator handy. And then you can post it and you'll be good. Any questions, as always, feel free to email. If you need a Zoom meeting, I'm more than happy to help you with that way as well. Have a good day.